So hi again, my name's Ryan. I'm with Blue Sky Energy Solar Charge Controllers and Genasun Solar Charge Controllers. We've been in business. Well, Blue Sky Energy started back in 1998 when it was back then it was called RV Power Products, and we pretty much brought MPPT technology to the commercial market. And it was out there before. I mean, NASA was using it and stuff like that. But back in the day, nobody had maximum power point tracking controllers. Later, we renamed ourselves as Blue Sky Energy because we wanted to put it on sailboats as well, not just on the RV market. Um, so today's pretty much a general discussion, and I try to keep it a little bit informal. So if you guys have any questions, I encourage it very much. Just raise your hand, and I'll call out on you. We're going to be talking about not just our charge controllers, but generally speaking, everything in solar that you can think of. Everything from batteries and how to charge them to different charge profiles. It seems like every year I come out here, people come to me afterwards like, well, last year I got about 50% of what you said. Today about 75%. And it kind of goes on and on and on as far as the retention. But there's no such thing as a silly question, and I do encourage them. A lot of times it lets me remember things I didn't bring up or any topics I didn't discuss. So it's just great, and I encourage it. Don't feel bad about raising your hand. To start off with, I'd like to talk about what is MPPT versus PWM. Now, MPPT stands for Maximum Power Point Tracking. PWM stands for Pulse Width Modulation. Now, your average solar panel, right? Let's just talk in a 12-volt panel. Of course, I would always have you reference specifications whenever you match it up to your controller. It gets a little confusing on the categories of panels, 12-volt, 24-volt, 30-volt panel, and it's got very little to do with their actual output voltage. But your classic 12-volt panel has an output voltage under load of around 18 volts, VMP, volts max power. Now, a PWM style charge controller, when it's trying to charge your batteries as fast as it can, when it's in bulk mode and it's trying to raise your battery's voltage, it basically connects your solar panel directly to your battery. And by doing that, it forces your solar panel to operate at your battery's voltage. So now instead of putting out 18 volts, your solar panel is putting out about 12.5 volts. So you're losing 20 or 30% of your power just because you're not operating your panel at its correct voltage. Now, a maximum power point tracking or MPPT controller will operate your panel at its ideal voltage, and then it does a buck type energy conversion. It's lowering the voltage but increasing the current at the same time. So for example, if you had 10 amps coming in at 18 volts, you'd have 13 amps coming out at 12 volts. The watts are the same, you're just maximizing your power. This gets more and more crucially important as you get to the higher wattage panels. Now, right around 200 watts, panels tend to increase their voltage. You have your 60 cell panels, your 72 cell panels, and on and on. And their output voltage can go all the way up to 36, 37, 40 volts. And so that gets even more crucially important, because if you've got a panel that's potentially putting out 36 volts and you're only dropping it at 12, well, you get about a 30-year power. You're really handicapping yourself. Any questions on MPPT versus PWM? It's pretty straightforward, but this is how it goes. I cover a topic and I ask for questions. The difference in efficiency is if your panel is operating, let's say you had a classic 12-volt panel, ask what the difference is as far as efficiency. Percentage-wise, it depends a little bit on the environment. Now, the hotter a panel is, the less voltage it will produce. Now, even if you're in Arizona and you can literally, well, you are in Arizona, but in Phoenix in the summertime, and you crack an egg on your panel, literally cooking it on your solar panel, that panel's output voltage is still going to be in the mid-15s. So the sun does affect it, but it doesn't affect it all the way down to the basement. So if you had good conditions like today, nice cool weather, you're talking about 30% difference on an 18-volt panel. Of course, if you have a higher voltage panel, that could be twice as efficient, 3 times as efficient, because you're going to want to operate 36 volts down at 12 volts. Now, moving on to the charging, right? Now, all of our controllers are programmable with every setting. Now, a lot of charge controllers will go, oh, this is my flooded setting. Oh, this is my AGM setting. Oh, this is my seal setting. We let you actually program all the voltages, any times, durations, everything under the sun, and so that you can actually pick what's right for your battery. We found that there's actually a wide variance in preferred charge voltages from the manufacturers, even among the same battery types. A Trojan T105 wants different voltages than a Deca flooded, an East Penn battery. If you have an AGM, a full river, wants drastically different voltages than a Lifeline AGM. So instead of just going lotta, we want to choose for you. We allow you to choose all those voltages. And also lithium, of course, has a different charge profile. Talking about the stages of charging, The first stage, so when your controller wakes up, woohoo, it goes up to your absorption voltage. Now, the first set point, the absorption voltage, used to be called constant, then it was called acceptance, now it's called absorption. It's kind of like an AA meeting. um, so if you have your controller, your actual controller says, hey, I'm in acceptance mode, and somebody else says, hey, I'm in absorption mode, same animal, the same set point, the first set point. Now that'll range between, say, 14.3 to 14.8, depending on your battery manufacturer's recommendations and what kind of battery you have. Now it's important to get on a lead acid battery, and we'll talk about lithium a little bit later, but it's really important to get to that first stage, the absorption voltage, in order to properly desulfate your cells. Now, to put simply, when your batteries discharge, the sulfates molecules, they attach to the lead plates, and that basically grows like a coral reef on your lead plates, called sulfation, particularly soft sulfation. And then as you charge your battery, that coral reef turns back into acid. And so it's really important for your particular battery to dial in their preferred voltage to make sure that everything, that chemical reaction happens and everything turns back into acid. And that's a lot of times where people have heard, for example, you never want to let your battery become too discharged. You never want to discharge it below 12 volts, below about 60% state of charge. And that's because if that coral reef grows on that lead plate too big, it's harder to turn back into acid. You'll also hear people say, you don't want to leave your battery discharged for a long period of time. That's because the longer that sulfation or that coral reef lives on that lead plate, the harder it more crystallizes and the harder it is to turn back into acid. The next stage of charging is you drop down to the float mode, the float voltage. And that'll be 13.2 to 13.7-ish, depending on which battery you have. Now, that transition from the higher absorption voltage to the lower float voltage can really be done in two different ways. Now, a standalone charge controller doesn't know how much current is reaching your battery. So it's just going to choose a time, or you can program your preferred time, on how long it'll stay in that absorption phase. The ideal time varies depending on how discharged your batteries are. It could need 2 minutes in absorption. It could need 4 hours in absorption. It really depends on how discharged your batteries were and how long they were sitting at lower discharge situation. So standalone, as an industry standard, we generally say about 2 hours is ideal. If you don't know, because we don't want to hang there too long, we don't want to hang there too small. And you might say, well, why don't I just hang out at absorption all day long? Now, the battery construction, if you look at a battery, you've got the lead plates, and then you got that secret sauce, everybody's industry secret, the secret recipe around these plates, or it's like a paste that goes around these plates. And the higher you stay at that voltage, the higher absorption voltage, the more you use up or degrade that paste. And that's what eventually causes lead acid batteries to die, right? Like that's why your lead acid battery only lasts 5 years, 7 years, whatever, right? It's a combination of no more paste, or that the sulfation becomes too hard to turn back into acid. Now, on the other side, you want to get to that high voltage in order to desulfate the plate, to turn that coral reef back into acid. So you play this game between, holding it up there just long enough, but not too long. So other than standalone time, I'm going to get to the absorption phase, I'm going to go there for 2 hours, then I'm going to drop down to float. The other way to base that transition is on the net current reaching the battery. Now, we have you do this by utilizing an external current shunt between your battery bank and everybody else, between all loads and charge sources. So I often tell people on how to install it, say, well, put your finger on every negative of every battery. The only thing touching that finger should be another battery or the shunt, with the caveat temperature sensors. Now, we do have a current shunt. It's utilized with our IPN Pro remote. And so now the controller, well, if your battery is at 14.4 volts-ish absorption phase, and your resting voltage of your battery is like 12.8, it's always going to take some amount of power to keep your battery at that higher voltage. So eventually that amount of power to keep it at that higher voltage becomes redundant, right? It's using that power for no reason. So a lot of battery manufacturers will specify how much power is that when it becomes redundant. Our factory default is about 1.5 amps per 100 amp hours of capacity. Full River, I believe, specifies 2 amps per 100. Lifeline specifies 0.5 amps per 100. So it does vary on what each manufacturer's, their float transition set point could be. But that works good in two ways when you base it on the current. Now your controller wakes up, woohoo, goes the absorption voltage. Now if your batteries are fully charged, it's going to go, oh, you're charged, boom, I'm in float immediately. And you're not holding that voltage unnecessarily long. Or reversely, if your batteries have been heavily discharged, or if you've got a lot of loads going on while holding that absorption voltage, it can hold it longer as needed, and that way it drops down to the float voltage when your batteries are actually perfectly fully charged. And this greatly increases your battery's longevity. Another thing to increase your battery's longevity, I always recommend with lead acid batteries, a battery temperature sensor. They're not very expensive, like 30 bucks, because batteries like to be charged at slightly higher or slightly lower voltages depending on how hot or cold they are. The colder the battery, the higher voltage it wants. The warmer, the reverse, the lower voltages it wants. And for a small investment, you can easily increase your battery's longevity by quite a bit. And of course, if everybody lives in Southern California and it's beautiful San Diego, 77 degrees all year long, or pretty close to it feels like, it may not be as important. But if you're a desert camper, or even if you're storing your batteries in a cold environment or a hot environment, it becomes more crucially important. And it's just one of those things I do recommend it for everybody. Any questions on charge profiles? And we'll, lithium, I'll touch base on lithium for just a moment. Lithium batteries, they have a similar charge profile to lead acid batteries. Now, everybody's got their own opinion on how to charge a lithium battery, and everybody's still learning. It's a new technology, and some people will say, oh, I want two-stage CCCV and just hold at 14.6 forever. Other people will do a multi-stage charge profile, and then their precise voltages will vary depending on opinion. Of course, I have my opinion, and I'm happy to share it with you, but I don't want to tell any battery manufacturers are wrong when they're trying to charge their battery. More importantly, when you look at your standard profile versus lithium, the float voltage on a lithium battery is going to be much higher if you do decide to go in a multi-stage charge profile. It's going to be about 13.6 if you're cycling your batteries every day-ish, and then it's going to be about 13.4 if you're basically going to let them sit for weeks on end in between. That's because traditionally you don't float a lithium battery. You don't want to provide current to keep its voltage maintained. So the resting voltage of a fully charged lithium battery initially will be like 13.6 volts, maybe a little higher, and that'll settle down a little over 13.4 volts after a couple weeks. So if you choose a set point beneath the voltage, then you're not actually providing current to maintain it. But you do have to pick a set point, because after you charge your lithium battery, you still want to maintain all the loads in your rig until the batteries, until the sun sets and you start utilizing that power, that renewable energy you made. Any questions so far? Yes, sir. He asked, if I get a lithium battery at Battleborn, a Life Blue, there's Relion, there's several out there. The chemistry is the same between them. Do I need a specific charger? Well, you need a charger that is able to be programmed you need a charger with variable programmable settings, right? So, and that's why I'm saying, specifically, the higher float voltage is more necessary. So if you have traditionally, you have a charger that floats a battery at 13.2, and you can't alter that, then at that stage, you're going to have a hard time because your battery is going to discharge quite a bit before your PV starts, taking up the load before the sun sets. So the charge voltage it ranges between 14.2 to 14.6 for a lithium iron phosphate battery. So it's really similar to most absorption voltages, but the float voltage is a lot more important. Also, the time spent at the absorption phase is a lot less for lithium batteries. Now, the preferred time varies among manufacturers. I've had some manufacturers say 12 minutes is plenty, and other manufacturers say, like Battleborn, 1 hour per battery. I think that's a little excessive, but that's what they want, that's what they get. I mean, if you had, I can almost live with 1 hour per battery bank, but the longer you hold a lithium battery at that charge voltage, or in a lithium world they call it the balancing voltage instead of the absorption voltage, the harder it is on the cells. And so that's one of those things, like, everybody's got their opinion. I'm not going to come and say Battleborn's wrong. They make the batteries, they make a ton of batteries. Follow their advice, no problem. If you start reading into this, you'll find that everybody has a different opinion, slightly, on how to charge lithium batteries. Well, I mean, yes, it's like any charger you buy is not suitable. It's too much of an open-ended question. I think a lot of chargers are programmable. Maybe a lot of chargers have set points on them, like their AGM setting might be suitable for a lithium battery, even though it doesn't say lithium battery, but you'd have to look at what those settings are. Um, a lot of times, a common AGM setting is going to have a low absorption voltage and a high float voltage in general. And so you very easily could have an off-the-market charger which is compatible. You would have to just look at that particular charger and determine it for yourself. But in general, you want a lower absorption time and you want a higher float voltage on the lithium batteries. And of course, all of our controllers are completely programmable, so you could change any parameter you want any which way from Tuesday, and you can just have fun with it. So I can't speak for all controllers in the world, but if you have any questions, I'll be happy to look at any data sheets or anything afterwards, see if I can help out solve that answer for you. Yes, sir. Yes. He asked, do AGM batteries have the same sulfation as lead acids? Yes, AGM battery is a lead acid battery. The difference is instead of having the plates sitting in the juice just floating around there, they have like a sponge next to the plate. And that's why you can orientate them in any direction, and they don't tend to lose water. They're all sealed environment. Now talking a little bit about equalizing batteries, right? Because we're still in the charge profile discussion here. Now, equalizing a battery is when you bring it up to a deliberately higher voltage in order to aggressively desulfate those plates. Now, that equalization voltage could range from 15.2 to Trojan's T105's astounding 16.2 volts. Woo! I haven't talked to Trojan personally. I'm like, really? They're like, yep. I'm like, okay, no problem. So of course every battery manufacturer can have a different equalization voltage, and of course you can program it on our controllers, and then very often you can pick it. Now often they say, how often should I equalize my batteries? Now same thing, when you equalize your batteries, you are using some of that secret sauce from your plates, but you're also keeping the sulfation off the plates, so you're going like this. As a rule of thumb, as an industry standard, you pretty much say you equalize for 2 hours every 30 days if you're actively cycling your batteries. So if you're out here and you're using your batteries every day, they say about 2 hours every month is ideal. If you're a weekend warrior, of course it depends on how much you use your batteries, but you might do it quarterly or biannually for a couple hours. Now a lot of people say, can I equalize an AGM? And that's the initial answer is like, no, you can't equalize an AGM. And I'm not telling anybody to go equalize their AGM. Don't take me to the bank on this one, right? The principles of equalizing and aggressively desulfating your batteries does still apply to AGMs, but with a sealed battery, there's no place for the steam to go if you get them too hot. So they can bloat and it can ruin the battery. Some battery manufacturers like Lifeline do give specifications because they actually have a little vent in their battery for reconditioning them. And they'll say, okay, you don't normally have to do it, but if you do, your batteries were severely discharged or they haven't been charged in a long period of time, fully charged in a long period of time, it can be beneficial. And they say you can go, 15.5 volts for up to 6 hours. Now, personally, when I have people, do lifelines, I say I'd rather you do like a half an hour a day for 2 weeks or 1 hour a day for 6 days versus 6 hours in a day. Because if your battery accumulates that heat and you lose those electrolytes, that water out of the batteries, there's no way to get it back in there, unlike lead acid batteries. One other benefit of equalizing a lead acid battery is when they gurgle, you're mixing the acid and the water within the battery. Because the acid is heavier than the water, it tends to settle, and then you get what's called stratification of your plates. So in essence, the coral reef is only growing at the bottom and not the top, and again, that makes it harder for you to use all that potential energy and to get it turned back into acid later on. Any questions? Yes, sir. Yeah, so he's asking about the BMSs and balancing the cells. Now, prior to working at Blue Sky Energy, same owner, I built about 1,000 batteries for these earthquake sensors up in Alaska, because Genasun used to manufacture lithium batteries for a lot of high-end yachts and stuff like that. And he's quite correct that most lithium batteries, the vast majority, do what's called top balancing. So they're not going to equalize the cell voltages until you get it to a particular charge voltage. Normally that'd be about 14.2 at the battery. And so a lot of times, and that's my preferred charge voltage or balancing voltage for lithium batteries. That's my personal favorite, 14.2. Now you have to realize there might be some resistance between your charge controller and your battery. There's always some resistance, but depending on your wire gauge distance, the current, you want to make sure it's 14.2 at the battery. That might make you to a 14.3 at the charge controller just to account for that. And also, when you charge a lithium battery, once you achieve that balancing voltage, it's pretty much charged. I mean, you're in the 90 plus percentile, depending on how imbalanced your cells may be. Unlike a lead acid battery, where you're charging at 20 amps, 20 amps, 20 amps, you get to absorption, it's like 19 amps, 19 amps, 17 amps, 17 amps. If you look at the lithium battery, you're going to charge at 20 amps, 20 amps, 20 amps, and as soon as you get to 14.2, it's like half an amp, like next to nothing. And then at that point, it's balancing the cells. Because unlike a lead acid battery, as you charge the battery, the cells don't come up at the same voltage at the same time. If you look at the charge profile of a lithium battery, they call it the hockey stick, because it goes like, and then wham, at the end. And as you get to the end of that hockey stick, this cell can jump up, and this cell can be a little slower, even though your series voltage is still 14.2, this cell is higher than that one. And so you need a little time to balance those cells. Another benefit of lithium batteries is they don't care if they remain discharged. In fact, if you store your lithium battery for long term, the book says you should discharge it about 30 to 40% and leave it in a discharged state for that long period of time. You don't want to fully charge your lithium battery and then stash it, for the summer or the winter, depending on, what season you have. You want to discharge it a little bit. I've got a lithium battery from the project I did. It's about 5 years old. It's still sitting in my closet, brand new. It's only charged 30%. In fact, when you ship a lithium battery, that's only the legal state of charge you're allowed to ship them at. It's about 30% in order to, obey all the laws and stuff like that. The amount of balancing time is a little dependent on the BMS and, of course, how imbalanced the cells are. But it ranges from 12 minutes to 1 hour, depending on whom you ask. Battleborn will say 1 hour per battery. Lithionics will say 12 minutes, is more than enough. Some people will say it's better not to balance the batteries every time, but at the same time, that way you're not you're not stressing the cells, and only balance them every 2 weeks. But that's one of those things where opinions really vary depending on who you ask. And I'm not going to say one person's right and one person's wrong. Normally, when I recommend a balancing time, I recommend about a half an hour. But that depends a lot on the balance and the cells, because as you match the cells, their Coulombic efficiency, that makes a big difference on how much of their balance time. So a lot of it is a TLC that people use to build a particular battery, because it's not just, you're not like a good cell, a bad cell, but to match the cells together so that charge rate on that particular cell is really, in tune with each other. But I always say about a half an hour. Other people would say 15 minutes. Battleborn will say 1 hour per battery. So if you had 2 batteries, they want 2 hours. But to each their own. I'll be happy to let you program whatever you want. I'm not going to say which is right and which is wrong. Yes, sir. What? Yeah. Well, yeah, inside the lithium battery, you've got your battery management system, your BMS. And your BMS does a few things. Like we discussed, it'll balance the cell's voltages once you reach your charge voltage. So in the end, they'll all be even Steven, 3.55 to 3.65 volts per cell. The other things a lithium battery management system can do, or has to do, is it makes sure your lithium battery doesn't get discharged below a certain point. If you look at the discharge curve on a lithium battery, it's like hockey stick, really stable, I'm off, hockey stick, and it just falls off the map. Now, with a lithium cell, if you discharge it below a certain point, you need to charge it really slowly, or else it explodes. And so what a BMS does is it cuts off your battery from any loads, preventing your cells from getting to that low voltage where it would be dangerous to charge them at a high rate. The other thing a lithium battery BMS does would be to disconnect the battery if the voltage gets too high. So that's another danger of lithium batteries. You don't want to overcharge the cells. So if you charge it past 14.6, disconnect voltages vary, but normally about 14.8, it'll also disconnect any charge current going to the battery. Also, a good BMS is also going to monitor the temperature of the individual cells, because you don't want to get Coulombic runaway. If a lithium battery cell shorts, for lack of a better term, it's going to start generating a ton of heat, and it can get dangerous. So most lithium batteries will also have temperature sensors on each individual cell, just for protection purposes. And then if you have a really good lithium battery BMS, you don't want to charge a lithium battery below freezing. You can discharge it below freezing, but you can't ever charge it if the battery is below 0 degrees Celsius. And so a good BMS will also monitor the error in the cell temperature and disconnect charge sources if the battery is below 0 degrees, just for safety's sake. Now, if your BMS doesn't have that feature, or you want to charge your batteries when it's super cold, they do make something called battery blankets. And that would fit, it's like an electric blanket. You put it around your batteries, and if it gets below 0 C, it'll drain a little bit of the batteries, use a little bit of power to keep them above 0 C. So there are a lot of stuff on the market in order to combat the 0 degree thing. I mean, also on a lead acid battery, you never want to charge a frozen battery, right? But the freezing point of a lead acid battery is a lot lower if it's fully charged. That's why people, more or less, if they're parking their car in the mountains and it's below freezing, you don't wake up to a frozen battery. It's because you have a lot of acid still in there, and so its freezing point is much lower. If you have a fully discharged lead acid battery and you put it in sub-zero temperature, well, yeah, it can freeze up, and in that situation the same. You don't want to try to charge it because it can get dangerous. Yes, sir. Good question. He's asking the chemistries of the lithium batteries. Now, just about all the large capacity batteries, right, are lithium iron phosphate, or LiFeO4, LiFePO4, right? And that's going to be common. So any of these like Battleborns or Relion, they're always going to be lithium iron phosphates. The other chemistry is lithium cobalt slash lithium manganese or lithium polymer. So the kind of lithium technology you have in your phone, or for most of the electric bikes or those scooter thingy dingies and all that, those are lithium ion, Li-ion, which is referring to the category of the 18650 cells, the Sanyo 18650 cells mostly, and they look like a little double A's, and they stack a bunch together, and they don't get as many charge cycles, nearly as many charge cycles, and they're also a little more dangerous. Those are the ones that can catch on fire. You could take a LiFeO4, lithium iron phosphate, and you could toss it in the campfire. It's not going to burn, right? It's not going to stink. It's going to make a mess, but it's not going to cause this big fire. It's not the same with lithium Li-ion, lithium manganese, lithium cobalt, lithium polymer. Those have a lot of potential energy, and they're not as safe. So really, unless you're talking about an electric scooter, electric bike, or something like that, you can just assume it's a LiFeO4. Anything over 20 amp hours is pretty much guaranteed to be a lithium iron phosphate and not the Li-ion. But there's a lot of confusion out there. I've seen a lot of people describe lithium iron phosphate as Li-ion and vice versa. And so you want to make sure you know what you're getting. But I wouldn't be too concerned about getting the wrong one, because unless you're getting something off eBay or Alibaba, you're not, any reputable site is going to, steer you the right way. But you do want LiFeO4, LiFePO4, lithium iron phosphate, definitely. Any questions? Woohoo! All right. And I'll do a little bit more lithium batteries here and move on, because I also want to cover a lot of the troubleshooting. For Blue Sky Energy and Genasun, I do product support, which means all day, every day, people call me with problems. So I do want to cover some of those items before we get going, because I want to make sure if your system's not working right, you can always help troubleshoot. Of course, always happy to call me. One more thing I'll talk about lithium batteries is the capacity. Just like we talked about on a lead acid battery, you really don't want to discharge it below 60%, about 12 volts, because it's hard on the battery. That means if you have a 100 amp hour battery, you really have about 60 amp hours effective that you can use out of that 100 amp hour battery, if you can only discharge it like 60%. In the lithium batteries, you can use about 80 to 90% of its capacity. That means if you have two batteries, they're both 100 amp hours, the lead acid you got 60 to work with, and the lithium you got 80 or 90 to work with. So the effective amp hours, the amp hours you can use. So it's just something to take into consideration. I know everybody's getting really excited about the lithium market, and so are we. And if you're counting how many amp hours you have now and how many amp hours you want in equivalent as lithium, keep that in mind. Also, lithium batteries are a little more efficient when you charge them. When you charge a battery, it always takes some power to make that chemical reaction happen. It's called the Peukertz factor. So when you charge a lead acid battery, you pretty much keeps about 9.5, 9.4 amps for every 10 amps you give it. It's got about a 92, 94% charge efficiency. And lithium batteries are more like 99%. So you are going to get about 7% more power into your lithium battery just because there's a lot less resistance to make the chemical reaction happen within it. Another thing, so you, for example, I have X number of watts of solar. That's going to be more efficient when charging your lithium battery because there's less resistance within the battery you know, to make that chemical reaction happen. Also, with a lithium battery, if you have a lithium battery system and you don't have a battery monitor, like our IPN Pro remote with the current shunt, I really do recommend them because I spoke a little earlier about how stable the lithium battery's voltages are, and you really don't get any warning when your battery's going to cut off on you. It's gonna be like, you know, 12.8, 12.8, 12.8, 12.8, I'm off. Unlike a lead acid battery, you can see, oh, my batteries are getting down to 12.2. Maybe I should turn on the Jenny. So you really want a battery monitor that's going to take into account all, like our IPN Pro remote display, that monitors all that current going in and out. So now you have actual state of charge information based on amp hours. At a 200 amp hours, I have about 190 left. I'm 96% charged. That becomes a lot more important when you have a lithium battery as compared to a lead acid battery. That he asked, what about vibration on lithium batteries versus lead acid? Truth be told, I guess it's going to depend on the particular lithium battery manufacturer. I haven't ever heard of any going bad in that fashion, but obviously you've got electronics inside a battery, and that's a lot of the TLC on how the particular one is built. I haven't heard any of it going bad in that way, but I'm also not an installer, in general, so I don't have customers coming back to me and saying, hey, my battery's not broken. I have heard good things about support for most of the popular brands. Like I heard Battleborn's got good support for a line. I've never heard of bad support for any of these lithium batteries, and I'm sure customer service and product support on those guys can help you out. And you can mail a lithium battery. You can go UPS on a lithium battery. It's not like it is still considered hazmat, but it's not like you can't just put it in a box and go. So I'm sure if you do need to warranty one of those, you can just mail it out to the manufacturer versus, driving it there wherever it is. Any other questions so far? Yes, sir. Well, I mean, I don't want to speak one brand versus another, right? You can discharge a battery until it cuts out. Now, I can say I have experimented with the Battleborn battery, the Dragonfly version of the Battleborn, and I basically, I put a 5 amp load on it. I put my watt meter on it. This is for an African project we were doing, putting solar in Africa. Woo! But we wanted to test the capacity and more specifically the voltages of the battery. So we wanted to keep, if we wanted to have a disconnect voltage, we wanted to save a few amp hours for standby power. So I cycled the Dragonfly version of Battleborns several times, and sure enough, 100 amp hours out before it cut off every single time. Of course, that's going to be a little dependent on your loads as far as the voltage sag. If you have a 20 amp load on a battery, its voltage is going to be lower than if you have a 5 amp load on a battery, just because of the pressure. When you're drawing battery, its inherent pressure is going to be low. So the battery's basing its cutoff point on voltage. Yeah, you might not get 100 amp hours if you're drawing 50 amps of it, but on a modest load, I can say at least on the Dragonfly Battleborn, it was 100, it was 100, it was 100 when it cut off. I found that at a 5 amp load, their disconnect voltages didn't quite agree with what I was observing as far as the state of charge left. And so we played with it a few more times, and I'll be happy if you need to know like a LVD cutoff switch for the Dragonfly. I'll be happy to forward you what I discovered on my personal testing versus that. But that, again, that could have just been a load difference. They might have had a 1 amp load on their battery, and that would affect the cutoff voltage versus the capacity, or with the state of charge of the battery where it was left. But it was consistent, and I did get 100 amp hours out of it every single time before it turned off. So I was impressed for that. Any questions? Yes, sir. Yeah, I agree. He was asking or making the comment of, lithium batteries are lighter. Ooh, they're a lot lighter. They're talking about a quarter to a third of the weight of a lead acid battery. So I completely agree with that. And also they have higher energy density. So if you look at the form factor, most of them, but if you look at the they do have higher density, but depending on the enclosure they use, you look at the form factor. For example, if you're keeping one battery underneath your step, and that's the only place you can put batteries, you're going to get away with more amp hours underneath that step with a lithium battery. Also, like I mentioned, if you have a 100 amp hour lithium, you've got about 80 to 90 to work with before you're on the tail end of the hockey stick. If you've got a 100 amp hour lead acid battery, you got about 60, 65 to work with before you start damaging it. So not only is it more compact as far as energy density, you get to utilize more amp hours out of the particular of that you have more energy, more power in there to use. Any other questions? Okay, here's my favorite one. here's the great debate: series versus parallel. Which is better? Now, I'm not going to say one's better than the other. I just want to describe the benefits, pros and cons of the two different setups, okay? And then everybody can make their own choices. Now, when you combine two panels together, and for this example, I'm just going to be talking about a 12-volt, 36-cell, 18 volts under load power. Standard, like if you had a 100-watt panel, you have 18 volts under load. It's going to be about 5 amps, 5.5, 5 amps. Just call it 5 for easy reference, right? Now, if I have two panels connected in parallel, connect the reds together, connect the blacks together, doubling the current, keeping the voltage the same, right? If I take one panel alone and I put my hand over it, its output voltage is going to go from 18 to like 17, maybe 16 and a half. You're going to lose about 7%, depending on how big your hand is, of course, and how close, to the sun. But you're going to lose about 7% of your panel's output voltage of that, right? But that same panel, I put my hand over it, its output current, or its IMP, amps max power, is going to drop down to like 2.5. Now, if I combine two panels together in parallel, basically the lowest voltage tries to dominate. So now, if this one's at, 18 volts, I put my hand over it, it's 17 and a half, 16 and a half. Now this one's 16 and a half. Now, that's not 100% accurate. I mean, each panel can only draw so much power or load from the other panels. So I don't want to say that's going to be a total, but it's a little bit like combining two batteries together. If you have a fully charged battery and you've got a dead battery and you connect them together, you're going to have a dead battery, right? The voltage is going to pour into that lower battery. The higher voltage is going to charge into the lower voltage. So when you combine a panel in parallel, the lowest voltage will try to dominate. So for example, as far as voltage goes, this panel, its current still dropped to 2.5, but since its voltage dropped to 16.5 and lost 7%, I'm only losing about 7% of this other panel. Now, when you combine two panels in series, you're basically doubling the voltage. You're tying together like two 6-volt batteries, and the current remains the same. And when panels are connected in series, the lowest current dominates. So now if I put my hand over this panel, and it's down to 2.5 amps, its buddy's down to 2.5 amps too. It bottlenecks that current. So now in series, instead of losing 7% of my power, right, I'm losing 50% of my power. So there's no arguments that partial shading, when it comes to partial shading of an array, that parallel is always going to win. Now there are some caveats. A lot of new panels these days have integrated bypass diodes, which means if you have 3 panels and you shade one, it's trying to bottleneck the current, the power will flow right around it, so it doesn't take down your entire array. But you'd still lose that entire panel as the bypass diode, is active. So there are, it's not like most panels these days, a lot of the modern ones do have bypass diodes, and they can help when you put all these series strings together, and from just have the whole thing taken down because you've got one corner of one panel shaded. The downside of in parallel wiring is the size of the copper, right? And when you're working at those lower voltages, depending on the distance of your array to your charge controller, you might need bigger wire, more copper for less resistance. So the other argument on the other side on the series would be that, okay, when the sun condition's really low, when it's cloudy out, and it's raining, my voltage will still be enough to charge my batteries. Now, in order to charge your batteries, any charge controller, most any charge controller that is intended to buck the energy down, the input voltage from your panels needs to be higher than the battery voltage. And so if it's really, really rainy out, 2 panels combined in series, they can have a higher input voltage to your charge controller, and you'll still be charging. But for the most part, even yesterday in the 2 cloudy days, when it was like really overcast, I was still charging on this panel, 18 volts out. The sun angle doesn't really affect the output voltage or the sun in general, like partial shading, sun angle, cloudy weather, you're going to find that your standard panel is still going to output above battery voltage. Um, and it's one of those trade-offs. Would you rather have partial shading when something casts a shadow, drag down the array, or do you want to try to, double up your power and have, on a really crappy conditions, still be charging at like 1 amp? I'm talking really crappy situations. You'd have to be really, really bad weather for a standard 12-volt panel not be able to charge a 12-volt battery, like really bad. And it really depends on the environment you're camping. If you're out here and you've got a flat roof, nothing on it, and you're just camping in the desert all day, well, a series might, there's no real, downside against it. If you're like camping in national parks and such, and you might have a little tree, or your panels are kind of located next to a vent that you think might cast a shadow on it, well, then parallel might be better. So those are the basic differences, series versus parallel. If you're, the amount of copper, partial shading, and of course make sure your charge controller is compatible with whatever voltages you choose, right? You don't want to, I do have several customers that blown up a controller because they put too many panels in series and, they're like, how come it doesn't work anymore? I only put the 4 in series, like 150 volts, Our controllers aren't designed to take that. Some are, some aren't. Any questions or comments on the great debate? Huh? Okay. Yes, sir. Okay, and like a good question. It's like, okay, if I do decide to go in parallel or in series, whatever my voltage is, how do I know what gauge wire should I utilize? Now, as a rule of thumb, you want to try to keep your voltage drop or your resistance under 3%. That's just a rule of thumb. Of course, the less the merrier. So that depends on how many watts you're putting on the roof, and also the distance between the charge controller and the panels themselves, of course. Um, and also you want to keep in realistic mind that most panels only produce about 70% of their rated output in real life, especially if they're flat mounted. If they're flat mounted this time of year, expecting about 50%. So when you start gauging your wire, don't keep in mind that you can derate your panel's wattage by like the 70% of its output, because there's no need to have a wire this big if you're never going to get that much output. But for example, generally speaking, you have 400 watts of solar, you've got about a 15-foot run to your controller, 10 gauge is fine. If you have like 600 watts, 15-foot run, maybe 8 gauge. Just as a rule of thumb, based on my experience when I have crunched these numbers. It's not that 10 gauge is going to burn up on you, but you're going to lose some efficiency because the voltage at the controller is going to be less than it could be. So you lose some efficiency and resistance in the wire, but it never becomes a danger. Um, yes, sir. I mean, okay, so I can speak for our controller. So we do have a couple controllers. He asked, I have a controller that's compatible with both 12 and 24 volts, and also I have a 24-volt panel, right? Now, like we mentioned before, in order to charge your batteries, the input voltage has to be higher than the battery voltage. So your classic 24-volt battery, no, sorry, 24-volt panel will have an output voltage of about 36 volts under load, VMP. It's on a 72-cell panel. You want to stay away from using the 60-cell panels because they have an output voltage rated at about 30 volts, but sun angle, panel temperature, stuff like that, you can start dragging that down in the 29s and 28s, and so your 60-cell panels may not be sufficient to charge a 24-volt panel. Technically call those 20-volt panels, but I've seen them called 24-volt panels. I'm always like, look at the specifications, right? Don't look at the category. So our particular controllers, when you initially connect the battery to it, if it's a 12 or 24-volt panel compatible, if it sees a voltage above 16 volts, when you first connect the battery, it assumes it's a 24-volt system. If your battery voltage is less than 16 volts when you initially connect the battery, then it assumes it's a 12-volt system. And that's how our controllers decide between the two. I can't speak for everybody out there in the market. A lot of people say, well, what are the benefits of running a 24-volt system? And basically, what it comes down to is your inverter. when you're taking your DC and you're turning it into AC, that conversion always takes some power, right, to make the switch. Now, if you're coming from 12 to AC, it's going to be less efficient than if you're coming from 24 volts to AC. And so you lose less power when you make that conversion. Now, most of us with inverters and such, we're not drawing a ton of power. Now, if you have a ton of solar and you're running, and you have like a commercial refrigerator that you're running on AC all the time, that's where sometimes it can be beneficial to get that higher nominal battery voltage, because the majority of the power you're drawing is going to be for that refrigeration. Refrigeration is the mother of all loads. That, microwaves, crock pots, and hair dryers. I mean, a microwave will draw 90 amps at 12 volts easily. Hair dryers are up there too. So if the majority of your power is for this big refrigerator, you're going to save a lot of power, and the efficiency be changing. And then what you would do is you would get a 24 to 12 volt converter, DC-DC converter for all your regular 12 amp loads. And buck that down for your lights and your LEDs and such like that. It's not like you'd have to replace everything in your rig to be 24 volts compatible. You would. Okay. Excellent. Uh, there's a first. So, any questions on nominal battery voltage or anything like that? Yes, sir. Well, there's no, I mean, a watt's a watt, right? And I'll talk a little bit like monocrystalline versus polycrystalline panels in a moment, but a watt's a watt. So if you have, a 100 watt 60 cell panel, or it's moving like 200, right? If you have a 200 watt 60 cell panel or a 200 watt 72 cell panel, you still have 200 watts of power. So that doesn't affect the actual output. I was referring to the voltage when charging a 24 volt system. Because if you have a 24 volt system, your absorption voltage is going to be like 29 volts, 28.8 volts, right? That's pretty high up there. And in order to charge a battery, the input voltage from your panels has to be higher than your battery voltage. Now, most 60 cell panels are rated about 30 volts under load, 30, 31 volts under load. Now, conditions, panel temperature, sun angle, dirty panels, that can easily cause that 31 volts at STC to come all the way down to like 29 volts, 28 volts. Now all of a sudden your input voltage isn't sufficient to charge a 24 volt battery. Now if you're charging a 12 volt battery, who cares? You're way above it. And if you hopefully you have an MPPT style charge controller, and it's going to do that buck type energy conversion, so you're still going to utilize all that power into your 12 volt system. That was just because he was speaking specifically about 12 versus 24. I wanted to make sure that if you decide to do that, you better take a look at your panel's output voltage. Speaking of types of panels, you've got monocrystalline, which is basically those ones that look like the squares with the little corners cut out. We see some white within the panel. And you've got polycrystalline. Those are the ones with those like purple, blue hue, and they look like little rectangles all over the panel. Now, 100 watt mono gives the same amount of power as 100 watt polycrystalline, right? Now, you might hear that they say monocrystallines are more efficient, right? Now, 100 watts, 100 watts. That's got nothing to do with efficiency. What they're talking about is the footprint. If you look at the size of a 100 watt polycrystalline panel and the size of a 100 watt monocrystalline panel, the mono is going to be smaller. It's going to be a smaller footprint. So that the efficiency of the cells is better. They can get away with a smaller footprint. Now, monocrystalline panels tend to do a little bit better. I'm not talking this much. I'm talking a little bit better with temperature. Their temperature tends to drop less when they're hot. And polycrystalline panels tend to do a little bit better with partial shading. If you partial shade a polycrystalline panel, its voltage drop is going to be a little bit less. But these are percentage factors in like the ones and twos, right? These are not leaps and bounds. So if you end up having a polycrystalline panel, don't think, man, I wish I upgraded to mono. Very small potato difference. Very, very small difference in the construction. The major difference is their size. But if you're in Arizona, and it's, we are in Arizona again. If you're in Phoenix in the summer and you can cook an egg on the concrete, well, perhaps, a monocrystalline panel would be a little more beneficial to you in that situation. Any questions? Yes, sir. Uh, I mean, okay, first question. Are lithium batteries price going to come down? I would assume they're going to come down a little because that's the market. The more people start selling them, the more people they have competition, and capitalism 101, it tends to drive the price down a little bit. But the cells themselves have a certain cost, the technology has a certain cost, so I wouldn't expect it to come down drastically. But yeah, the more people they have to compete with, the more that I would think the price would come down. As far as having two different inverters, commercial fridge and not a commercial fridge, I would say no, because if you have, then you have two different battery banks, right? And now that you're playing this whole game, I'd rather have one battery bank than like one battery bank for this and one battery bank for that. Because as I put on solar and I put on my renewable energy, I want everything to go to one. I don't have to be switching back and forth. You know, it's a lot easier to just go with a larger battery bank and get a DC-DC converter for your modest DC loads. But that's, of course, everybody's got their own opinion. I'm not going to say one's right and one's wrong. But I would just keep it with 24 nominal and then do a DC converter to my 12 volt bus bar, and that's how I would handle it. This is just a 100 watt, 12 volt HQST panel. Uh, that's a monocrystalline. If you can see white, it's a mono, and that's I mean it's I just got that on Amazon, Amazon Prime, $100, buck a watt. You know, there's a lot of good panels out there, and you don't have to spend leaps and bounds. And I get mine from Amazon because a lot of cost of solar panels these days is the shipping. And if you're a Prime member, woo, it just shows up. Well, yeah, one second. Not. I'm not. I'm not here to sell. Do I sound? Does it sound like a good deal? Yeah, it sounds like a good deal. If you're getting a lithium battery for under $1,000 for 100 amp hours, that sounds like a pretty good deal. But I really haven't priced the market, and I'm not going to say one's better than the other. But that sounds like a pretty good deal. Yeah. There's a show special today. So yeah, so to let you know, he was saying there's 850 for 100 amp hour Battleborn in the tent. Yes, sir. What? I understand. He's asking a general question about inverters, and what it comes down to, there's two types of inverters out there. You have modified sine wave, and you've got pure sine wave, right? And so as it makes the power, right, a pure sine wave is going to be very smooth, like this. And the modified sine is more choppy, boom, 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 boom. In general, you always want pure sine wave. The only thing modified sine wave is good for is like power tools, like a rotary, a rotary tool, because that's just a simple motor. All your electronics are going to do better with pure sine wave. And in general, unless you're like kind of food truck and the only thing you're running is your compressor on your refrigerator, pure sine wave. That's just one of those for sure. You're not going to want that to bite you in the rump in the next. Awesome. So on his question, he's asking, fusing what kind of fuse, right? How many amps? So you want to rate your fuse to about 10 amps over your controller's max output. So if I have a 30 amp controller, I'm going to put a 40 amp fuse in it. Now, and that's more, especially if you're using like a DC breaker, like a Blue Seed, DC breaker, you don't want to run those at their max. Now, if something tragic goes wrong, get water on your controller, wire shorts or something like that, your batteries has hundreds and hundreds of amps available, right? So really, that's there for short circuit protection. It's not going to have a hard time blowing should something drastic happen, up the line from it. So it's not, I'd rather go a little bit over on my fuse size and just make sure you don't run into issues. Speaking about fuses, not all fuses are created equally. That is for sure. One of my nemesis is in product support, flexible bladed fuse holder. I'm talking wiggly wire, plastic box, wiggly wire. Now, I'm not saying they're all bad, but I can say for the last 3-4 years I've been doing this job, 1 to 2 times a month, every single month for my entire career, I've had a bad fuse holder on for a customer. Not the fuse holder goes bad. I mean, they make some good ones. Blue Sea makes one, Little Fuse makes one. They make some decent ones out there. But the majority of your AutoZone, Radio Shack back in the day, whatever type fuses that you get, and you think they're good, no, 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 no. They fail, and they fail in a way that's really hard to tell. Sometimes it's voltage drop. Sometimes it just stops working. My personal favorite, I like A and L style fuses, Alpha November Lima, right? You can get them. They range in quality from you can spend $40 for a fuse and a fuse holder, or you can spend $12 for a fuse and a fuse holder. But it's a fuse that goes in and it tightens down. There's a bolt on either side of the fuse. There's nothing to wiggle loose. There's nothing to go bad. You have an eyelet terminal and a bolt, and that's my preferred style fuse. They don't go bad. They don't wiggle loose in time. I mean, again, I don't want to dive too far into like too much specifics on like inverters and installs because everybody's rig is different, and I don't want to give too much. I don't want to give bad advice. Of course, on an inverter, if you're using an inverter, you need to have a transfer switch. You can't have the same circuit of your AC circuit from your inverter shared with your shore power when you're plugged in. So some people have automatic transfer switches, and so the power is routed through their inverter so it can recognize where the power is coming from. Some people have manual switches. So, I mean, if possible, I'd have you draw it out for me, and I'd answer that question after the show. Yeah, kind of. Again, that's very specific. He's asking some specific questions as far as I'm not an inverter expert. Of course, I'm an installer as well, and I'd love to like draw it out because I like to give good advice on that. But I'm afraid I'm gonna have to see it written down because it's a little bit of pressure, and I don't quite understand your concept. I understand. I think I do, but I don't want to speak such a specific situation. Happy to talk to you afterwards. I'd love to. Okay, moving on to do you need a fuse on your in? Oh, yes, ma'am. Excellent question. Okay, she's asking. I'm just reiterating for everybody. She's asking, what if I have panels on my roof and I also want to have panels, a remote panel? Do I need different controllers? Right. There's a two-part question to that. It's a two-part answer. Now, um, obviously, if your controller's rated to 600 watts of input and you've got 300 on the roof, you could connect 300, remotely, and that's not gonna bother anybody. Now, when you combine different panels, we talked a little bit before about series versus parallel. When you combine panels in parallel, you have to make sure that their output voltage on their load is ideally within zero point 0.5 volts of each other. Just like if you shade one panel and drag down, you don't want a panel with a VMP of 19 connected to a panel with a VMP of 18, ideally, because now the 19 is going to come down to about 18. So you can match different wattage panels. They don't care on parallel. I don't care if this one's 150 and this one's 50, as long as the output voltage VMP is ideally within zero point 0.5 volts of each other. Now, talking more about yes and no answer. Now, let's say you have panels on your roof, but the reason you have remote panels is because you want to pull under the shade, and then you want to put out this other set of panels, right? Now, there's two ways you can attack that. You can have two different charge controllers. Our controllers have the ability to be integrated together in a master-slave network, up to 8 controllers. So you can have all your displays and everything like that in your main controller, and then you could have a smaller controller connected to the network, and so you just plug the input into that. You have a little like SAE plug or Anderson connection or something like that at your pump out port or wherever that you can just plug in your remote panel to, and that way both controllers would operate as a single unit even though they're optimizing their arrays independently. Now, if you have a large controller and you have the extra capacity of that controller to add more panels, but you still want to pull your rig under a tree, what you can use is you can use a blocking diode or an anti-reverse diode. And they sell the MC4 click-in style. If you go to Amazon, anti-reverse diode, you can buy those. And what that does is it prevents backfeeding from the panel. So you would connect that on your roof panel to your main array. And that way, if you pull under a tree, your remote array wouldn't be able to backfeed into your roof system. But the downside of that is blocking diodes in general cause about a zero point 0.5 volt drop. They cause a little bit of resistance. And so you're going to lose whatever, like 4%, 3%, what depending on what your voltage is, you're going to lose a little bit of power all the time from your roof by making this, by making this concession to have the blocking diode in there. So it really depends on how much capacity you have on your existing controller, and ideally, I'd rather get if you have our controllers, get a slave and tie it into the network. And that way, when you're looking at your state of charge and your batteries and the output, all those displays are going to reflect the gross output of all the controllers in the network, even though they're optimizing each array independently. Okay. You were saying there's a better solution versus blocking diodes. If you can give me that information after this, yeah, if it does the same thing. If you can, yeah, I'd love information on that because that's the first I've heard of that. Okay, so I'd love any information on that for sure. That'd be great. He was saying that there's a solution out there, and we can. I don't want to go into too much detail because I don't understand it. He can explain it better than us, better than me because I don't quite understand it. But he said there is solutions out there that will substitute blocking diodes, and they won't cause that half a volt drop inherently. So he said there is solutions for that. I'm as curious as you are. Yes, sir. No, they don't. A lot of solar panels these days, he's asking, I thought all solar panels have blocking diodes. That's a lot of solar panels internally will have bypass diodes. So that's how, if you have one cell and you put your hand over the cell, you don't take your whole array down. The power will flow around that cell, and that's what allows it. You just lose that string, or it depends on how you're particular. You might lose that cell, you might lose that string. For example, military panels, they have one blocking diode per cell. And that way, if you shoot the solar panel, you only lose 1/36 of your power and not the whole string. But they have bypass diodes internally. In the old days, they would have bypass or blocking diodes in solar panels, where people would wire them because at night a solar panel can be a load to your batteries, and so people would have these blocking diodes in there, and that way they wouldn't be a load. Most modern charge controllers are going to have a relay or a MOSFET in there that's going to prevent the backfeeding from the batteries into the panels. So super old school panels, people would have this, they'd try to get this panel with an output voltage similar to an absorption voltage in their battery. They would go unregulated to their battery, but then the blocking diode would prevent that battery from being discharged by the solar panel at night. But so internally they have a bunch of bypass diodes, but not blocking diodes. And blocking diodes really aren't necessary except for the scribe thing where one's in the tree and one isn't. Yes, sir. Yeah, so order a connection, right? He's asking if a panel's live, it's in the sun, can I connect it to my controller? Now, when you're connecting panels to a controller, our manual says, okay, you want to connect the battery first and the solar power. The order connection really doesn't matter when you're first connecting it. So when you're connecting it, battery first, solar first, I don't care. Speaking to the owner or chief engineer, he'll say that connecting the solar panel first is a lot better because if you accidentally short it, if you short your solar panel's inputs while the controller is energized, you're going to kill your controller, right? And even a fuse won't save that on the panel side. So if you just for a safety with wiring, it is a little safer if you don't cross the streams to connect your solar first and then your battery. Because if you spark your battery wires, that spark goes to the battery, blows the battery fuse. If you spark your solar wires while it's connected to the controller, while that controller is energized, then it's going to kill your charge controller. That's one of the reasons why I don't recommend that you put a fuse on the input, your PV input. We normally do not recommend fuses on the input side because, little known fact, you could take a solar panel's output, solar panel's wires, twist them together, put it in the sun, panel doesn't care, doesn't break the panel. And even if you have a fuse, if you short those inputs while your controller is energized, it's definitely going to kill the controller. The fuse just doesn't react fast enough to save the controller. So having a fuse on your input side, I'm not saying don't do it. I mean, it's a little better for lightning, but generally speaking, minus lightning strikes, and sometimes they don't care. They'll just bridge right across a blown fuse. Aside from lightning strikes, that's just one more thing to go wrong in the system. Now, you do want to make sure when you disconnect your batteries that that there isn't solar power available. and that's because it's called a load dump. And that goes for any car controller. Like, you don't want to have your converter actively charging and disconnect the batteries either, because if we think of it as a fire hose, you've got this fire hose and it's pouring water, and all of a sudden you take the batteries away, and that water has no place to go. I don't care how fast you are on that nozzle, that water is going to splash against your hand a little bit, and that splash ends up being a voltage spike or load dump. So if you do disconnect your batteries from any charge source, it's recommended to remove the input first. Now, if you're talking solar, you could disconnect your batteries at night. You could throw a blanket over it, or you could physically remove your PV input wire. Or if you had a fuse or a DC breaker on your input, you could switch it off. But you just want to make sure, as a rule of thumb, any charge source, you don't want to disconnect the batteries while it's actively charging, because any other electronics in the circuit can suffer a voltage spike because of that load dump. Because, I mean, electricity operates about a tenth the speed of light. You're asking a lot for the firmware in there to shut off at that instantaneously. It's really not possible. I've never particularly had our controllers damaged by this. I've had a ton of people disconnect their batteries while actually charging. One of our controllers, one of the little settings for some reason switches. It like flashes the EEPROM in the load dump, and I have customers have to go back and change a little setting on one of its auxiliary output options. But I've never had a controller break because of it. But that still doesn't mean it's a good idea. Yes, sir. If you plan on removing your batteries, I mean, right. He's asking, I disconnect the battery when it's in. He's asking, well, how do I keep this load dump from occurring, right? And so, yeah, you could have a DC breaker on your PV input, and that way you can switch off your solar, assuming you're putting it in storage in the daytime. Of course, you could put your storage at night, and just, as long as you flip the battery disconnect switch when the sun's down, I don't care. Controller's not actively charging. But if you're trying to put it in storage, during the daytime, and your solar's actively charging, and that would be beneficial. That's a much easier way to handle it. And it's not hard. DC breakers are really cheap. They're not really cheap, but like 30 bucks, for a 30 amp breaker, 25 amp breaker. And I'd recommend Blue Sea, not Blue Sky, but Blue Sea, because they just make ridiculous good stuff. Just one second. Switch is fine too. Okay, switch. A lot of times I say DC breaker because, I even forget that switch is an option. But again, if you buy a switch, buy a good switch. Don't buy the cheap Radio Shack switch. Get a marine grade switch, and also keep in mind that your switch has to be rated to the voltage, the appropriate voltage. A lot of switches are only rated to 32 volts because they're automotive style, and you want to make sure that your switch is rated to whatever your a little bit above whatever your panel's open circuit voltage, because not all switches, if you had a standard 12 volt panel, sure, but if you've got a 72 cell panel coming in at 44 volts open circuit, your standard automotive switch won't be rated to it. You got to make sure you get a high voltage switch. One second. Yep, all back there. Yeah. 1 second. I'll get you next, sir. You can see him behind him. Yes, sir. Yeah, go. 86. No, we haven't. No, we haven't. We've considered it, and that's something that we may push forward in the future. But at the same time, we don't we don't provide the fuse as well for between the battery and the controller, so that you're getting this gets a lot of the particulars of the installation. And so if you try to sell the controller, but then you want to sell everything that goes along with it on the installation, I understand what you're saying, but if I have a PV off switch on my controller, a lot of people, I'll get a lot more tech support calls for sure, because people are going to start turning off their controller. It's not working. Did you turn it on? You had a question, sir? Oh, yeah, exactly. So he's asking how should my solar be wired? If I have a battery disconnect switch, should my solar be wired directly to my battery, or it should be disconnected on the disconnect side of the switch? Now, that's a two-part question. That's a kind of a double-edged sword on that one. Now, a lead acid battery has a monthly self-discharge rate of about 12%. Okay, AGMs are about 2 or 3%. Lithium batteries almost zero, less than 1%. So if you've got a lead acid battery and you disconnect it, those batteries, while just sitting there, are going to discharge. And as they discharge, they're going to sulfate. The longer that sulfation lives on the batteries, the harder to turn back into acid. Like, that's the downside. So on one hand, it's like, yeah, man, you really want to have your solar charge controller, charging your batteries all the time. Now, all of our controllers are programmable. If you're in storage mode, I would recommend, and you have a standalone controller, not with the shunt. So I don't want you to hang out absorption for 2 hours all day, every day with a fully charged battery. And so if you have a standalone controller and you're putting your rig away for the summer or the winter, depending on where you live, a lot of times recommend a different charge profile for storage mode. Because because our controllers are so programmable, what you can do is you can tell the controller to hold the float voltage forever, but every now and then, every 2 weeks or 3 weeks, go to the absorption voltage for a couple hours, just to make sure those batteries stay completely desulfated. And that's just a bunch of settings, and that's a really easy thing to do. Back in the old days, they used to think that if you keep your battery at 13.2 forever, then it's going to last forever. Woo! I'm floating it forever. That's perfect, right? But then you might have heard the expression, you should exercise your batteries every now and then. You might have heard that. Like, every now and then, if you keep your batteries stored, you should exercise them. It's not so much that you want to exercise them. What they're saying is you want to trick your charger into going to the absorption voltage every now and then to keep them desulfated. So that's not so much, you don't need to charge and discharge them, but you do want to get them into that 14.5 zone every now and then, even when they've been maintained at 13 volts forever, just to make sure they stay perfectly clean. Now, in any setup, I would always recommend in this kind of situation, or any rig, I like the battery disconnect switches, but I also like low voltage disconnects, LVDs, right? Now, for example, I had somebody in the marine application, and they got a boat down in the Bahamas. And they call me up like, Ryan, I love your products. We've had them forever. Every year I leave my boat in the Bahamas. We leave a couple fans and bilges on just to keep the air circulating. And we've been doing this for like 12 years. Came back to my boat. My controller had failed, and now I lost all my batteries. I lost $2,000 in batteries or more, right? And my response, of course, like, man, that sucks. Is like, well, why didn't you have a low voltage disconnect, an LVD? A low voltage disconnect goes between your battery bank and everything else. And it says, okay, if my batteries get below a certain threshold, I'm shutting them down. I'm acting like a self-acting battery disconnect switch. And so that's the backup plan. Because I would say, in general, yeah, man, you really want to keep the solar on there. You want to keep your batteries topped off. But God forbid, my controller fails after a number of years. Or a tree falls on it, or there's snow cover forever. My controller is going to have a little bit of a parasitic draw, not much, but a little, in standby mode. And I'd hate if something goes wrong for that to be the thing that tanks your batteries. So you could have an LVD in between my controller, and they're not expensive, especially if the one just between a controller and the battery. It's not going to be rated a massive amount of current. You can pick one, a Blue Sea makes a real nice one. It's like $80 and it's rated 150 amps. It's okay. It's like 80 amps continuous, 150 for 5 minutes intermittent. And that's just one way you could solve that problem. Because I want to keep your batteries topped off, but it's the same thing as having a computer and all your precious information on it and nothing backed up anywhere. One day your computer's going to stop working. What's your backup plan, right? There's got to be a contingency plan in there.
What's your recommendation when I hook up to shore power? Do I disconnect the panel?
Excellent question. He says, what happens when I connect to shore power? And that's the expand on that. I say, can I have multiple charge sources on the same battery bank at the same time? The answer is yes, absolutely you can. Now, specifically, all batteries, even your car, all battery chargers, even the alternator in your car, basically has 2 modes. It'll either provide constant current, bulk mode. It'll give everything it's got trying to raise your battery's voltage, or it'll provide constant voltage, CVs. That's what you see like CCCV, constant current, constant voltage. Constant voltage is where you're providing enough current to maintain a voltage. Now let's say, for example, and you'll get it in a second, okay? Let's say, for example, you have 20 amps of solar available. Okay, your controller wakes up, and your car wakes up, whatever, and it brings it up to 14.4 volts, the absorption voltage. And later in life, now it's only taking like 5 amps, even though it's 20 is available, it's only taking about 5 amps to maintain that voltage. Now, if you put a load on the system, let's call it a 5 amp load, that load's going to try to make the voltage fall. So the controller's going to say, oh, voltage is falling, I'm going to turn up my output. Now it's putting out 10 amps, 5 to the battery, 5 to the loads. And then you say you take away that load. Now the voltage tries to increase. because it's only the only battery only needs 5 amps, so it turns down its output. So it's providing enough current to maintain a voltage. Now, if you have multiple charge sources, basically the highest voltage wins. Let's say, for example, your Magnum inverter is floating at 13.1 volts, and our controller wakes up in the morning. Now, when it first wakes up, both our controller and the Magnum is going to be trying to do 100% to raise the battery's voltage to 13.1. Once the battery gets to 13.2, the Magnum inverter is going to have 0 amps out because it's just trying to maintain 13.1. It says if the voltage is higher than 13.1, I turn down my output. Lower, I turn up my output. It's providing constant voltage at a set point. So if our set point's higher, our controller is going to keep on going. So if you look at like charge profiles, with multiple charge sources, the highest voltage is going to attempt to dominate the charge, the charge cycle, or with the voltage of where it's at. It may not have enough current to get there. You do need a minimum amount of current to charge batteries. The rule of thumb is about 3 amps per 100 amp hours of capacity to make the chemical reaction happen within the lead acid batteries. So I've had situations, for example, somebody has a 400 amp hour battery bank and they're trying to bring up a Trojan T105 to 16.7, but they only have like 10 amps available, and they're like, or 8 amps available, and they're getting the 15s, but they're not getting all the way to the 16 too, because they just don't have enough power to make that happen. Also, I've had situations, speaking a little bit about trying to get to the equalization voltage. I've had customers that did have enough power, they're punching out 30 amps, and they're like, Ryan, these 3 old Trojans, I finally went to go equalize them, because he told me it was a good idea, and they've been cooking for like 3 days, and I just can't get them above 15.7 or 15.8. I'm like, well, set your equalization to 15.7. Your batteries became sulfated, and they're just refusing to get that higher voltage. Not the end of the world. So if batteries age, they can be resistant to get to that higher equalization voltage, but just make sure you have enough output current from whatever charge source, might be your converter, might be your solar charger, to make that happen. Any questions? Well, so no. So for example, you would leave it, yes, because there's no reason not to. The only reason I would say you might want to disconnect your solar would be if you have a standalone controller and you're not able to program it into a storage mode charge profile, because you don't want to maintain on a fully charged battery that absorption voltage for 2 hours every day, all day, if you can help it. On any of our controllers, you can just change the settings. But if whatever controller you have, you can't do that, and you don't have a shunt so it can base that transition to float on the current, I don't want you to use up that special sauce, that paste, on those lead plates unnecessarily. So most converters are going to be multi-stage, and they'll just hold the float voltage forever. But if you do have solar and you're not able to adjust the profile, then that solar is going to override that float voltage and hold that higher voltage, perhaps unnecessarily so, depending on, if you're fully charged or not. So that's like the one caveat.
So if you've got a set of panels sitting on the ground, an outboard controller, and you put your battery in, disconnect the sun. Now I'm leaving. You're saying unhook the panel, then unhook the battery, put the controller.
Yeah, I would. Yes, ideally, yes. I would say, yeah. He's asking like the order of disconnect. Since your remote panel is a charge source, right? Now, like I said, it depends on the controller, right? Now, our controllers usually are not damaged by this, right? And it's just as a rule of thumb, it would be better. You could take your panel and turn it around away from the sun, and then disconnect it. I mean, that's probably the easier solution than like trying to disconnect your panels from the controller. You could just turn your panels away from the sun. That way they're not producing any current. That way when you disconnect your charge controller from your battery, there's no load dump associated with it. Same thing goes. Yes, sir.
I got 200-watt, two 100-watt panels, and I was inquiring about using an MPPT controller, and I was told that what I would gain probably wouldn't be worth the extra price of the controller.
Okay, he's asking, and I'm just reiterating so everybody can hear. He's asking, I have a 200 watt, remote panel, and it's got a PWM style charge controller on it, right? And he was told by an associate, a friend, that the price of the controller doesn't justify the extra energy. Now, you get about 20 to 30%, we'll call it 25% just for a nice nominal average, right, of extra power from their solar panels, from a classic 12-volt panel with an MPPT controller. So if you have a 200-watt setup, then you're talking about, 50 watts here, right? 50 of the 200 watts is what you'd gain. Now, also, you're going to want to derate that because, like I said, most panels don't produce, 100% of their SCC rated wattage, which is why a lot of panels will give you NOCT, normal operating cell temperature, PTC, PVUSA, or NM, the newest one is NMOT, nominal module operating temperature specs, more like a real life expectation. So you would guess, oh, I would say 50 watts, but I'd say realistically, that's probably more like 40 watts in the real world, maybe 35, because I want to keep realistic expectations. So 35 watts divided by, 12 and a half volts, you're talking about 3 amps, right? Now that it depends on how much a difference that means to you. 3 amps for especially the remote panel is going to be tilted, so you're going to probably get about 7 hours a day. That's about 21 amp hours in a day. So it really depends, and that's not insignificant amount of power, especially you add it up over time and time. So I mean, if you have a 100 amp hour battery, and you're going to getting 21 more amp hours into it, then that's a fifth of your battery state of charge by increasing in your charge, improving your charge controller. If you have a 400 amp hour battery, 21 amp hours may not be significant to you, but that's how that math works out. You take you average about 25% more power with the MPPT controllers on your classic 12 volt panel, and you figure, okay, that's your wattage. Take a realistic D rating for real life conditions, divided by battery voltage, and Bob's your uncle. That's so in general, I love power. Especially with the foldable kits, they're super expensive. And we do have very simple, not very expensive charge controllers that will go for 200 watts. A lot of the Genasun, I have data sheets for it, I didn't bring them out right here, but all the Genasun controllers in this community are super, super preferred because they are RF silent. Silent. Completely. And so if you guys look at the Genasun controllers, I know like even Kristen will tell you, she's got a 3024. I do have a lot of giveaways. I have a lot of ferrite connectors because one of my solar installers really never put them in, but for FCC. So just as a thanks, you guys showing up after the show. If you need some ferrite connectors, they'll take down any noise. Feel free. I'll give them out. No big deal. But the Genasun controllers are renowned in the community as far as just being completely RF quiet, like as quiet as anything has ever been invented. So people go out in remote applications. You go to a little battery, and you want you put your antenna and sit in the field and not have any noise. It just doesn't happen. The Genasun controllers in the RV market aren't that popular because right now the largest one is rated to about 150 watts of input, which is fine for maintaining a little battery, but it's not as popular when you get these larger solar arrays and people want a 40 amp controller, 25 amp controller, or these massive controllers. Yes, sir.
What do you think of the panels that's got the controller mounted right to them? Is that very efficient?
I don't. He's asking, is it efficient to have the controller mounted at the panel? I mean, it really doesn't make a huge difference. Between the controller and the panel, it's about 18 volts. Between the controller and the battery, it's about 13 volts. Not a huge difference. Of course, 18 volts is going to suffer less resistance than 12. Not a huge difference, but if you are able to have your controller network together with your existing system, we talked about a little earlier, that's always going to be a better idea because A, it's going to be MPPT, B, it'll make that transition with the current shunt if you have an IPN Pro, and all the charge cycles will happen together. But I don't think it's a huge difference. You can also use, for example, our 1524 charge controller is rated 200 watts of input when charging 12 volts nominal, but it's got a 46 volt input. So you might, in that situation, you might be better off using a 1524 networked into your system, and then you can come in, you could take your two little panels, but combine them in series. Now you're rocking, 36 volts to your thing, and you can run, I did the math on it, was like you could run 80 feet with 10 gauge wire and still have your volt drop under 3%. It's like, so that's one way you can attack your remote panel situation, and I won't get too much into our product specifics. If you're interested in that, of course, I'm always available to help.
Another question.
Yes, sir.
What about taking two of those panels with the controllers on them and tying them into your battery? Good deal or not good deal?
I mean, the more solar, he's asking, what about two remote panels into my battery?
With
Well,
controllers.
controls, yeah, but he's asking with two different controllers, two different remote panels into my battery bank. That kind of falls in the same discussion of multiple charge sources on the same battery bank. Sure, go ahead, knock it out. I always make a joke. I was like, there's two types of people in the world: those that ask if they have enough solar, and those that brag about being in float mode by 11 a.m. Right. I just on that note, before I forget, I just want to say, in town we've got a couple of real nice, reputable installers, both Solar Bills and Discount Solar, do impeccable work. They're super nice, family-owned businesses, and they're a huge supporter of us. So I just want to put a shout out to them. If you guys need any solar resources, or you need an expert, or you want to have an install done that's never ever going to go wrong, those guys will take care of you. So just putting that out there before I forgot, because I come out here and I do seminars with them, and they're like family to us. Are you talking about? He's asking the GB10. What is it rated to as far as the input, right? So basically, on if you provide if when it's rated to 140 watts, right? But then again, that's 140 watts actually working, equating to 10 amps out. So you can derate a panel like a 150 watt panel is not going to give you 140 watts. It's going to give you like 110 ish, right? But if you provide excess current to the GB10, the controller goes into current limited mode and it operates slightly above its mechanical ability level. And factory default, that's designed as a safety feature and isn't designed for prolonged use. We do have the capability of doing a custom firmware. We do so we make the current limited mode operate just below its maximum output. So it'll be outputting like 9.5 amps maximum. But in that situation, you could put conjillion watts on it. I don't care. It's still going to put out 9.5 amps no matter what you do. And so in that lot of situations where people want to put over 150 or 170 watts, or they want to, or we have situations, for example, like the panels are out in Alaska, right? And there's like, wow, when the sun's really low in the sky, I need to have a ton of panels connected to it just to get 10 amps. But in the summer, one panel would be fine. What do I do? And in that situation, we just reduce the current limiting on the firmware, and that way you can use it all day long, and it won't ever give any trouble with excess PV input. It would never damage the controller. We can the GB10 PB12 is because any controllers that have the jumper that change the charge profile can't be reprogrammed. But just talk to me after the show. I'll hook you up. Okay. I always have some extra, used boards around that I can reprogram and just mail out to you and give to you, and that's part of the show benefit. You know what I mean? If that's what you want to do. Yes, sir. Yeah, and so he just made a comment on, you know, make sure you get the right fuse for the job, right? I mean, like, if you get even like my recommended A&L style fuses, the one that Renogy sells, the cheap ones, they're not that very expensive, but you get like the Blue Sea one, that's a whole lot better. That's not gonna, if you blow it, it doesn't explode. Some of the other ones I've heard can actually like literally explode. It'll break the circuit. I'd love any information you have on like your preferred fuses above, A&L or preferred manufacturers. Um, I don't know too much about, that particular comment, but I'd love to learn more. Okay. Yeah, assuming a fuse has a data sheet was a whole nother story. Yeah, yeah, yeah. Good quality fuse holders are always best. Now, talking about that, I also wanted to cover a little bit about the, I promise, like troubleshooting. Now, obviously, fuse holders is an issue, right? Now, another time, let's say somebody calls me up and says, Brian, my controller is no longer charging, or it's charging at a very less than expected rate. And the first thing I'll have them do is, look at the input voltage. Generally speaking, your input voltage should never be below 15. I don't care what kind of panel you have. But one of the main killers out there, and probably the most overlooked killer out there, is mismatched MC4 connectors. Now, the MC4 connector is that waterproof male-female connector that pretty much every solar panel is sold with. Now, you would think within the industry, they click together okay, they're all compatible, right? Nope, not at all. They don't really do studies on motorhomes, on mohos as I call them. They don't really do studies on motorhomes, but they do studies on residential panels. And 95%, that's a huge number. 95% of residential panel failures are due to mismatched MC4 connectors. I can give you the link. It's from RV Magazine, right? RV Power Magazine. That's 95%. Because you would think they'd all be compatible, but there's no third-party regulatory, guidelines on making these MC4 connectors. So the tolerances as they mate, specifically the innards mate, the materials they use as they mate, are specific between manufacturers. And so every panel just about in the world, when you buy it, comes with MC4s attached. I've never seen one come with a little baggie with its mating pair, right? That means the vast majority of panels out there have mismatched MC4 connectors. So I always like to say, okay, if you're gonna use MC4s, buy some nice ones, and then put them on and connect, do the male and the female. They're not hard to do. It's a little kit. You can connect both sides. If you use MC4 combiners, like the Y combiners, the 4-to-1, 3-to-1 combiners, so you put them all in parallel. Okay, if you're brand X combiner, buy brand X, male and females to go with it. And that way you're within the same manufacturer, and that's going to save a lot of trouble because they fail in a way that's so difficult to troubleshoot down the line. So difficult to troubleshoot. Basically what you do with troubleshoot it is you're looking at the voltage and the current. Mostly the current is what determines you the most. So for example, you check the short circuit current with the wires disconnected. Never test your IS. Oh, we got a timber. Thank you. Sorry. Awesome. Thanks for your help, guys. Um, you would check the short circuit current on, just like testing a solar panel. So there's a video on our website in our learning center how to test solar panels. When you test a solar panel, you make sure it's disconnected from the charge controller because that's super important. Don't test an ISE. You look at its open circuit voltage, its VOC. It should be, within a couple volts of its rating. But then you take your meter, you switch it to current, and you check the current coming out of your panel. Now, just like most panels only produce 70-ish% of their output wattage in real life, they're also only going to produce about 70% of your rated current in real life. Bad panels tend to give almost no power, almost zero current. And so a lot of times you'll okay, they test each panel, 5 amps of this panel, 3 amps of that panel, 5 amps of that panel. You should have 13 amps at the bottom. They reconnect these MC4s, they test on the bottom, 2 amps. I'm like, bad MC4s, chop them out. Solder and heat shrink never goes bad. um, I love, especially if you use a pre-glued heat shrink. You put a little clear silicone on their solder joint, and then you do heat shrink. Any questions before I move past the MC4? Watch out, watch out. Okay, I don't want to take you guys too much of your guys' time. I would like to say, Blue Sky Energy finally got Bluetooth. Woo! It's not quite yet for sale. We're ironing out a couple bugs, wrapping up our injection molding and stuff. It'll be for sale in a month or two. But I do have a demo model up here. I'd love to show you guys. Some of the better features of it are not only does it tell you all the information A to Z in a tabular form, it also does automatic data logging. So it'll data log, standalone, it'll data log up to 3 months of data at a half an hour granularity, 24 hours a day. And it'll also graph that data for you if you like, so you guys can see what your battery voltage was doing last week, last month, last year, and how it was dipping and up, and your input current. So it's really, really nice. It's completely feature rich. There isn't anything you can think of that, and if you can think of anything on there we haven't thought of, please let me know. But good luck with that one. We try to cover every single base. You can increase your 3-month. If you put an SD card into it, then you can get years out of it. So you just pop in a little, SD card like for a camera, and that will increase your internal storage capacity from 3 months to years on end. Any questions? I don't think I missed anything. Yes, sir. Yeah, I talked about it a little bit earlier, but you want to, yeah, no problem. If you have a lithium battery, you want to make sure you utilize, I would say recommend you utilize some kind of battery monitor. And you can just disconnect those if you like. Just pop them off the top and roll them in. Everybody give him a hand. No, but I'll be happy to show you. I have an example of a current shunt over here. But Since it seems like the display is saying I need to wrap it up. I'm not going anywhere. If you guys have any further questions, I'd very much like to answer them. We can kind of do it in person. I just want to say thank you so much for having us. It's been great. And I have those ferrite suppressors for you guys, so come by here and I'll give you some. No big deal.